So this is part 261. It says line 22f1d Arrhenius Thermodynamics Quantum Activation Energy 5G Wow Seti. So there's your alien radio signal there, and here's a diagram for you to look at. This is our RS plot. We're talking about this again. This was in the last video as well. Arrhenius plot LNK against 1T, quotes from WIKI RS equation. In short, the RS equation gives the dependence of the rate constant K of chemical reactions on the temperature T, and absolute temperature kelvins, and activation energy EA as shown below. Sorry, I thought I had these bigger. K equals AE minus EA and RT, where A is the pre-exponential factor or simply the pre-factor, and R is the universal gas constant. Alternatively, the equation may be expressed as K equals AE minus EA to KBT. Statistical mechanics or statistical thermodynamics is a branch of physics that applies probability theory. So here we have another theory coming up, which contains mathematical tools for dealing with large populations, to the study of the thermodynamic behavior of systems composed of a large number of particles. So when you're dealing with the 24 neutrinos, you're probably going to want to look at these equations and use them, because we're going to make 24 neutrinos by splitting them into 4 quarks. That's the goal anyways. So thermodynamics and kinetic theory. Quantum tunneling refers to the quantum mechanical phenomena where a particle tunnels through a barrier that it classically could not surmount, involving electrically charged particles interacting by means of exchange of photons, and represents the quantum counterpart of classical electrodynamics. In quantum electrodynamics, the anomalous magnetic moment of a particle is a contribution of effects of quantum mechanics, expressed by Feynman diagrams with loops to the magnetic moment of that particle. The magnetic moment, also called magnetic dipole moment, is a measure of the strength of a magnetic source. The Dirac magnetic moment, corresponding to tree-level Feynman diagrams, which can be thought of as the classical result, can be calculated from the Dirac equation. It is usually expressed in the terms of the G factor. The Dirac equation predicts G equals 2. So for particles such as the electron, this classical result differs from the observed value by a small fraction of a %. The difference is the anomalous magnetic moment, denoted A and defined as A equals G minus 2 over 2. So obviously when you're trying to make your 5G force for the UFO engine, you're going to want to take a look at this type of formula, okay? So we'll go on to our next video.